Hey everybody! So in this video, I just wanted to cover a fun little project that I've been developing just for my own personal need that I thought would be a cool kind of idea for a video to help people get a little bit more familiar with function graphs and pixel processor nodes. So in this video, we're going to be able to create this split viewer node that I have here. And the idea is that just based off of dragging this little GUI element here, we're able to kind of pan between and kind of like compare two side-by-side images based on our inputs here. But we have a couple different parameters we can play with, such as inverting the sides of these inputs, can change the split direction, and again I can drag this up and down depending on the images we input. I can also go and change the line color and the line width. So if I bring it down to 0, we don't have any width there. And we can bring that all the way up. And these are all very customizable parameters that we'll take a look at throughout the video. As well, I can go ahead and actually use this same exact node for color images. So it's not just specifically grayscale. If I bring this in, we can see that it's going to have all that functionality still with color images. And this is purely just for debugging purposes. I generally find myself using the crop tool in the blend nodes a lot, but I find that it's kind of a bit of a pain to set up, and I like to just go and start clicking and dragging in here. So it ended up being a fun little project, which I hopefully get to share with you right now. So to get started with this project, the first thing I want to do is go ahead and create obviously a new package that we're going to be putting all of our nodes in and developing this asset. But I also want to go and create a testing graph. So this is going to be just another empty graph that's going to allow us to start playing around with the node as we're developing it, so that we don't have to be plugging in and dropping in, these procedural nodes to test with in the actual working graph, in case we forget them, or it just kind of gets pretty messy when we start developing in the graph or testing in the graph. So what we can do here is instead create this test graph and then just click and drag and drop this in. And this is going to be the node that we're going to essentially work on. And then the last thing I want to do to set up our working station here is set up contextual editing. And now in a later version of Designer, this might already be enabled. I don't truthfully know. As you can see, I'm still rocking 2019. But in order to do that, we have to go up to Edit and Preferences. And then if we go down to graph, there should be this graph editing in context. And again, in my version, just because it's so old, it's still marked as experimental. So you can go ahead and enable that, click apply, and then OK. So now what we can do is if you go and either right click on this node that we're working on or hitting Control E, we can actually jump into this instance of the node, but we're actually developing the original master node, which is really cool. So now to get started on our node, let's go ahead and add inputs and outputs, which is going to enable us to see what we're working on as we're working on it. So we'll type in inputs, and because I want to be able to input both color and grayscale, I'm going to be doing both of these inputs here. But I generally tend to start with grayscale. So I'm going to select grayscale. And now the identifier is what we use to provide a unique label or handle for this socket specifically. So if we had two grayscale nodes, which we will in a minute here, this is how Designer is able to interpret between these two and know which one is actually what. I'll just call this input gray 1. And I'm going to give it an actual readable label of gray 1. I'll capitalize that G. And then I'm going to put this into a custom group, which I'm going to call gray. It's just going to provide that black bar background on these nodes and kind of group them together when we can see them on the actual node. And finally, I'm just going to give this a usage of any, so that we can plug in pretty much any grayscale information into this. It's non-discriminatory. So then I'll just go and duplicate this node here, giving it a new label of gray 2. And then I'm going to repeat this process with my color inputs, but I'm going to do that off screen. And now once I've got my inputs all set up, let's go and create our output. And we're only going to need one because, we're only outputting one final kind of compiled image here, or it's just going to be the split view or comparison between the two images that we input. And again, I'm just going to leave this as output. We can give it, a unique label if we want, like split view. And then I'm just going to leave the rest as default because really we're not using this anywhere else in the pipeline. It's really just to look at the node and the 2D representation once we set that up. And now that we've got our inputs and our outputs set up, I'm just going to click back into our test graph. So stepping out of this graph that we're working in into the kind of master graph that we have here. We can see that we've got both our grayscale inputs and color inputs here, and then we have our split view. So if I double click on that, now we're going to be able to visualize what's actually going on in this node. So I'm going to click and plug in my two grayscale elements here, and then I'm going to go back into this node. And if I go and just start to double click on both of these grayscale inputs, we're going to be able to see both of those nodes we just plugged in, which is awesome for us as we're working. Now here's a couple of the custom parameters we're going to be using throughout this project, and I'm going to get you to create them right now so that when it gets to the actual function graph component of the video, we're going to have these variables already set up for us. So the first one we're going to do is creating a float2 variable with the position editor type, and it's going to be our divider position. So we're going to be calculating the X and the Y position of this little GUI handle that we're going to get. And this is what's going to allow us to create that split between the comparison view of the two different images. The next variable or parameter is going to be a float1 with a slider type, and it's going to be for our line width. So this is going to just essentially be a 0 to 1 slider, which will allow us to create a thick or thin dividing line essentially in between our compared images. And if we go all the way down to 0, it's just going to completely remove it. Our next parameter is going to be of type integer1, and it's going to be a drop-down list. And this is going to be our split direction parameter. So we're going to learn how we can actually create a different split direction based off of this drop-down list so that we can have our images either split horizontally or split vertically, which is going to be pretty cool. And finally, the last parameter we're going to create is of Boolean type, and it's going to be just a simple button press. So this is going to allow us to invert the sides that the images are being displayed on, both vertically and horizontally. It's going to work seamlessly for both split directions that we decide, and it's going to be pretty cool. So now that we've gone and created our custom parameters, let's start using them in a pixel processor node. So let's go and type in pixel processor. And I want to drag and drop in all of our inputs into this guy because this is where we're going to do all of the calculations for this graph pretty much. And so we're going to need all of the data coming into this. And then using our parameters, we're going to kind of intelligently tell it how to process this data. So clicking on our pixel processor, I'm going to want to stay within the color output because again, we're not using this node for anything other than just helping us visualize stuff. It's not going to be plugged into anything else. And then let's go and click edit to jump into the pixel processor where all of these functions are going to be created. So let's go and get rid of this float4. And if this is your first time within a function graph and specifically in the pixel processor, it's going to be a little bit scary because if you hit spacebar, wow, you're not going to recognize really any of these nodes. And most of these are going to be more than we're going to need, but we're going to dip our toes a little bit with functions and processing pixels. So the first thing you generally do in a pixel processor graph is you need to find the position of the pixels, because what we're doing effectively in this graph is, if I click on this little eye here, finding each position of the pixels and doing a calculation or some type of function or operation on it, right? Hence function graph. Designer gives us a pretty nifty variable to allow us to do that, but it doesn't do it by default. We need to go and actually input it into our graph here. So I'm going to type in get, and I'm going to want to get float2. So these get functions allow us to essentially retrieve parameters that exist within Designer, either built in or custom. And I'm going to want to get a float2 because each pixel, if we go back to our 2D view here, has two parameters, right? It has an X and a Y position. So these are two float values. So let's go and click on our variables, and we're going to want to select this $POS. And so these $sign variables are system variables that are built into Designer. They're in every function graph we're going to be able to use, and they're always going to be there given the type of the actual parameter. Awesome. So now how do we use this parameter, right, or this variable? Well, a very easy way to visualize what's going on is if we drag this out and we start to type sample. I'm going to hit sample color. And if we go and right click on this and set it as the output node, it'll turn orange in the background of the node. And you can see that we're now getting the result of the image that we input in our first slot. And now because we're in a function graph using a lot of programming terminology, this is technically input image 0, but it's the first item in our list of images. And we can see that we have all 4 of the images we plugged in. So here is our second input, and then our third and our fourth. But again, we haven't plugged anything into those. So if I go ahead and duplicate this, and then I select input image 1. Again, this is going to be our second input. We're going to need to figure out how we can use the custom parameters we created to effectively split our image down the center or wherever we want it to be and display image 0 on one side and image 1 on the other. Well, the first thing we can take a look at is using an if-else statement. And what the if-else is going to do is return either of the inputs depending on whether it meets the condition we provided or not. So we'll see here that we can plug in any data type into this node given the gray sockets here. So I'm going to plug in input 0 and input 1. And I'm going to set this as our output, but we'll see that we still have a condition that we need to satisfy. Right now, it's just going to present whatever's on the bottom, because in order to view whatever is plugged in on top, we need to present an argument that is true. And because we have nothing plugged in, it's going to be false by default. So if I go and just type in Boolean, this is going to create a just generic Boolean for us. And we'll see that as I plug that in, it's not going to change anything because, again, it was defaulted to false. But if I set this now to true, it's going to view whatever is in the first input. Now, just a blanket true or false is not going to be ideal for us, right? We want to be able to split this down the center. So we're going to have to use a little bit of math in some of our parameters now to actually figure out how we can split the sides of our image and figure out how we can set one side of our image to meeting that true condition while keeping the other side of our image on that false condition. And now if I quickly just jump back to my testing graph here and I click on our node, we can see that we'll get this little gizmo. And effectively what I want to find out right now is if something is on the left-hand side of our little GUI, which is this X value here, we want to set it to our one image. And if it's on the right-hand side, we want to set it to the second input of our images. So we're going to need to use this float2 value in our pixel processor node and compare it against the position of the pixels to create that condition, true or false, for our if-else statement. So coming back into our function graph, let's go and type in get float2 again, because now I want to be able to retrieve our divider position. Now, if divider position doesn't come up, chances are you may have selected the wrong get float option. Again, we want to get float2. You also want to make sure in our split viewer graph that we have divider position set to float to. And if both of those are correct, but you're still not getting it showing up, make sure that you have this parameter set within your split viewer graph here and not your test graph. In order for us to be able to retrieve these parameters with these get nodes, we can only work up one layer or one graph. So now that we have our divider position, I want to break apart and separate the X and Y positions. So to do that, we're going to want to look for the swizzle nodes. And because I just want one value for each, I'm going to do a swizzle float 1. So this is going to be our X position. And if I switch this to Y, this is going to be our Y. Now, in order to compare to our divider position, I'm going to need to do the same thing to our pixel position. So I'm going to just duplicate these and quickly plug them in so that now we have the X and Y for our divider here. And we also have the X and Y pixel positions for every single pixel on our image. And so now the question becomes, how do we take these float 1 values and create a Boolean out of them, stating that on the left-hand side of our gizmo here, we display one image, and on the right hand, we display the other. So what we're going to do with these values is compare them against each other, and the result of these comparisons is going to create our dividing line. So for our swizzle X here, I'm going to drag this out, and I'm going to type in lower. And we can see that we have a lower and a lower or equal. Specifically, we're going to select the lower, and we're going to compare the X position of the pixel to the X position of our gizmo here. And we'll see that this is going to provide us with a Boolean value. So if I bring this back over, and I'm going to get rid of our Boolean there, and I drag this in, now all of a sudden you can see that we're going to get this split line. And what's even better is if I go and drag this, it's going to update dynamically based on the X position of this dividing GUI. So that's pretty cool, but what if we want to do a horizontal split, right? And have a top and a bottom. So all we'll have to do is input our Y positions here, and all of a sudden we're going to be able to bring this up and down, and it's going to split between our two input nodes there. So pretty easily, that's going to be the bulk of the workflow, is just a couple of nodes and comparing float values or positions on our sheet. Now the rest of this video is going to be us fine-tuning this. So what if we want to switch between this horizontal or vertical split, right? Well, we're going to have to find a way to use our parameter to essentially switch between those two. And so where I want to do that is before we actually even start comparing our positions, I want to switch between whether we're using the X or the Y positions using our split direction as the determining factor. Remember that parameter we created, which has the drop-down list? So if I go and type in switch, we can see that we have a ton of different options for switch. And switch in our function graph works exactly the same way as it does in our pixel graphs. And specifically, we're going to want a float 1 data type with 2 inputs. So if we take a look here, we can see that this switch node has a value 1 and a value 2, which I'm going to plug my X and my Y in. But we'll see that we have a yellow socket up at the top, and this is going to be indicative of an integer data type, and this is what controls whether we're looking at value 1 or value 2. So here what I want to do is I'm going to type in get integer, and we're going to get an integer 1. And with this node, we're going to go and grab that split direction parameter that we created. And we'll plug that in. So now in lieu of our A value for this comparison, I'm going to plug in our switch. And it's going to look a little funky on our 2D view here for the moment. But I'm also going to duplicate this. And I want to make sure that I now plug in the X and the Y from our pixel position. And we'll go ahead and plug this in. So we'll see now I can go back and forth there. However, if I go and actually click on this node and change it from a vertical split to a horizontal split, now it's going to use the Y position instead. So I just quickly off screen cleaned up our graph a little bit, but all of our nodes are still here. And the final functionality that I want to get out of this particular pixel processor node is the ability to invert our sides, where we can have our left image on the right-hand side and right on the left just by a button press. And so while the math and the logic of that is relatively simple, it might not be immediately apparent to us. But if we take a look down towards the end of our graph here, what's going on right now is we're comparing everything, pixel positions and divider positions just left of our comparison node here, and that's going into our graph. And what we have going on right now, effectively what we want to do is invert that or create the opposite condition so that true is now false and false is now true. And so where we're going to need to take a look at is at our comparison here. So if we think about it, right, the opposite of lower is greater. So if I start to type in greater and make sure I don't have that node selected, if we start to type in greater, you can see that we have a greater comparison as well. And so I'm going to plug our inputs into A and B. And again, make sure that you have the inputs plugged into the same exact one for both nodes. You'll see that if I swap these really quickly and I just hit X on my keyboard to do that quick switch, nothing's going to change because we've effectively said the same exact thing as lower here. But if we go and swap these back so that they're in the same positions again, you'll see that we're going to effectively invert the sides that we're getting our images displayed on. So this is really cool and very simple, but how do we now switch between these two states or these two conditions, right? Well, if you recall, we've gone ahead and created that Boolean custom parameter, invert sides, and I want to use that here in our function graph. So I'm going to type in get Boolean, and let's go and grab that parameter there. And now we could do this a couple different ways, but I think the easiest way is going to be just another if-else statement because it accepts a Boolean as our condition. So if we have our invert sides set to true, I'm going to select this one, this particular display. And if it's false, I'm going to have it display this one here. Now if we take a look, I can go ahead and invert our sides. I can go and change our position of the split, and I can even go and change it horizontally as well. And it's going to update accordingly, which is going to be really, really cool and just honestly super duper handy. So it's neat that we've got it working with our two grayscale inputs, but how do we get it to work with our color inputs? So let's go and create just some uniform color nodes. And I want to go and plug these in as well. And make sure that these are different colors so we're going to be able to see them as they appear. And if I come down to our sampled images, let's just go and duplicate these and set them to our input image 2 and input image 3. So again, our third and fourth images. So we need to figure out a way that we can go and sample our two color images here as a pair over our two grayscale images. So I'm going to duplicate our condition here and just plug in our second and third input. Actually, let's just quickly go and clean this up using the Alt key here to create that dot node. So that now we can see if I set this as the output, we're going to be getting this instead. And now the way that I want to do this is by creating a new custom parameter in our viewer. So let's go back to our graph here, our split viewer graph. And I'm going to double click. And let's create a new parameter. And I'm going to call this one bool color space. And the identifier is probably giving it away. I'm going to be using a Boolean type. And we can just call this color space. Now for the labels, what I want to do is set the true option to be color, and I want to set the false option to be gray. That's just how I would prefer to work. Again, you can set this up however you like. However, make sure to keep in mind that when we go back into our pixel processor, that you're setting it up in the right order. So like we've done already with our if else, because we're going to be using a Boolean, let's go ahead and get that Boolean and get our color space. I'm going to be using another if else statement with our Boolean as the condition. I'm going to be plugging our grayscale into the else because remember we left it as false. And I'm going to be plugging our color into the if and setting this as our output so that now we can see color space is grayscale or color. And we can go ahead and still swap between the two. Our splits are going to work as well as our inverts. And it's all just going to work nice and seamlessly together. Awesome. So that's going to be pretty much the bulk of the functionality for this node. But I want to go and create a pixel processor node separate from the one we just did, which is going to allow us to create a line down our dividing line, either horizontally or vertically. And we can change the thickness and the color of it. So a little bit simpler customization, but it's going to really help us out at the end of the day if we need to try and find the comparison between two very similar looking images. So let's bring this over and create a new pixel processor node. And this is going to, instead of actually processing data that we input, we're going to use it to generate data. So we don't need to plug anything into it. And I'm going to set this now to grayscale because we're going to effectively create a mask with this node. And let's go and hit edit. And again, we can go ahead and get rid of this float. And so now first things first, let's go and search for get float to, because I want to go and grab our divider position, right? Because this line is going to be along the divider. We need to figure out where it actually is on our 2D image here. And like we did in the previous pixel processor, let's go and just swizzle out a float1 for both the X and the Y positions. So switching this one over to Y, that should be good. And like we had seen in the previous pixel processor node, I'm going to need to determine between whether we're in the X direction or the Y direction, because we're only splitting our image one of those two ways. So I'm going to do an if-else statement. Remember that we can use this for basically determining whether something is true or false. And I would plug our X into if and our Y into else. So if this condition is true, we're going to be using the X coordinate. And if it's false, we're going to be using the Y. But what custom parameter do we have that actually determines which direction we're looking at or which coordinate, right? Well, that's going to be our split direction custom parameter. So yet again, I'm going to search for get integer because remember it's an integer with our drop-down list. And we can go and select our split direction. Now we're going to have a bit of a mismatch here because we have an integer with a Boolean, right? And you can see that that's going to give us a red line because it's not the correct data type. So we need to somehow convert this into a Boolean. Well, if I go and look back at our custom parameters and we go and find split direction and we take a look, we can see that our vertical split, again, where we need to determine where the X position is on our 2D view, is going to be of integer 0. And again, horizontal split, where we need to determine the Y position of our divider, is going to be integer 1. So if we take a look at how we've set this up again, right? Like I said, if this condition is true, we need to pass through our X position. Well, because we're going to need our X position for integer 1, let's go and just compare with our first value. So I'm going to type an integer to get an integer to compare with. And let's go and type in equal. So if we plug these in, we'll see that we're going to get a Boolean output. And if I plug that in now, it's going to be all right. So what we're doing here is we're saying if our split direction, our little drop down here, has the vertical split or first item selected, in other words, if this value is 0 or equal to 0, provide us with the first input in this node. Otherwise, if this is false and this number here is anything other than 0, go ahead and give us the second input here, or I guess the third socket. Now, this only really works because we have two inputs, right? We have our 0 and our 1. If you somehow wanted to go and create new directions later on, say you wanted to be able to drag around and create these kind of unique or custom dividing lines, this system is going to fall apart. And you're going to need to really kind of think about how you'd want to update this to better suit that type of system. But because we're only going to have these two use cases with the node that I'm developing, this is going to be more than fine. So now that we've gone ahead and created the basis for determining whether we're vertically or horizontally moving our divider, let's go and create a range for our line so that we can start developing the functionality for creating a line width. And so in order to do that, we need to first create that range that I'm talking about that is always going to fit around our little GUI element here. So what we need to do, either for the X or Y coordinate, but for this particular example, let's just focus on the X. I need to find a range that fits on both the minimum and maximum side of our X direction, so that these minimum and maximum values become the extents of our range. And within these values is where we're going to create this dividing line. And then what we can do is use our line width parameter that we made custom to go ahead and either thicken or thin this range to create that line width. So that's a lot of theory coming at you very quickly, but let's take a look at what we actually have to do to achieve that. So we've got our, in this case, X position with our GUI here. I need to go ahead and subtract a value from this to get our minimum range. And I need to go and add to this value to get our maximum range, however thick we want that to be. So I'm going to take this value out and let's go and get a subtraction and an addition. And these are just going to be very simple, mathematics, add, subtract. And now let's go ahead and get our float line width parameter. Now, if I was to just go and plug this into both of our addition and subtraction, that's not going to be the most ideal scenario. And the reason that is, if we take a look at our line width parameter, is that we're operating on a scale from 0 to 1. And I'm actually going to just clamp that to true, right? So that we're getting 1 or 100% and 0, 0%, and every 0.01 step in between that. Well, when we're dealing with pixel coordinates or positions, even a difference of 0.05 to 0.06 is going to be a significant jump in our line thickness. So at the end of the day, we actually need to go and decrease that final maximum value But I still want to keep the slider from 0 to 1 because that looks a lot better and just feels generally a lot better than going all the way up to a small value that's even a fraction of 1. So what we're going to do here is instead we're going to use a lerp node or linear interpolation. If you're familiar with any other kind of like shader node code, you'll be familiar with the term lerp. So what this is going to do is it's going to use the x value to slide through essentially a range created by two other floats. So because we want to use the slider from our line width, I'm going to plug this in to our x. And then I now need to go and create the essentially maximum and minimum limits that we want to sift through this thickness. So I'm going to type in float to get just a constant number. And of course, I want our minimum value to be 0, right? We want the line to be invisible, essentially. So that's going to be our A, being our lowest value. And the maximum distance I want to actually traverse in our two-dimensional space is going to be a whoppingly low number of 0.01. Again, right, that's not very satisfying, we'll say, to take a slider up from 0 to 0.01. And so that's why we're going ahead and doing it here so that we still get the ability to go from 0 to 1 and every value in between. And it's just going to interpolate it for us here. And we can see I've accidentally swapped our nodes here. So I'll go and make sure that 0 is in the top, 0.01 is in our middle, and our line width is in the bottom. So now we can plug this newly created range into here. And actually, I'll just hit Alt to quickly clean this up. There we go. And that's going to look pretty good for our range. Again, we're still not going to be able to see anything, unfortunately. But in just a second here, we're going to be creating the final output for our mask, and we'll see all of our work in action. So we've done a lot of setup, but how do we start visualizing this in our pixel processor, right? Well, like we had seen in the previous pixel processor, how we're going to be able to see anything up on our 2D view here is if we go and find the actual pixel positions and start sampling and outputting some information. So I'm going to go and type in getFloat2 again. And this time we're going to go to our $ position for the pixel position. And again, we're going to swizzle these out to an X and a Y value. And now before we go ahead and do anything with these positions, we need to go and determine which direction we're going to be looking at again using our split direction node. So let's go and just quickly Control D to duplicate this. And I'm going to be bringing our X into the first value and Y into the second because we're still using our split direction here. And so now that we have these pixel positions gated out with our Boolean, let's go and start to compare them with the range that we've just created. So I'm going to type in greater or equal. In this particular instance, we're going to want to make sure that we're using greater than or equal. And I'll plug our output into A and grab our subtraction here and just plug that into our second option. And then I'm going to search for lower or equal. And I'm going to do the same exact thing, just plugging this one into our first option and plugging our plus or addition node here into the second option there. So what are we saying here, right? Well, we're effectively saying if the, in this case, X pixel position is greater than or equal to the lesser or lower extent of our range, this is going to be true. And if the X position for our pixel is less than or equal to the higher end of our range for our line width, this is also going to be true. So effectively what we've done is created a scenario where anything that's going to be true is within the range that we've created, and the pixels that form a band, either vertically or horizontally, within that parameter. So now let's go and just quickly make sure that we include an AND parameter or condition. So this is going to take two Booleans that will ultimately return true if both of these are true. And then finally, to go ahead and visualize this, we need to just convert this to a float 1. And fortunately, Substance Designer has a very handy node where we can go from Boolean to float 1. And now if we right click on this and set it as an output, we can see that we're going to have this white line that's going to follow the direction, in position I should say. And if I go and play with the split direction as well, this is still going to be able to follow our little GUI here. As well, if we take a look and I play around with the line width, you can see that our line is thickening or thinning based on the position on our slider. And again, this is much nicer to do 0 to 1 than it is from, 0 to 0.01. Not as satisfying. So that's going to be the entirety of this pixel processor. And if we come back out, we can see that we haven't attached it to anything yet. So let's go and I'll just add it onto this connection here, a blend node, and we'll have this run to our output node here. And now what I want to do is take this pixel processor and plug this into our blend here so that we're going to be using it as a mask effectively. And then I want to create a uniform color node. For optimization, let's bring this down to a 16 by 16 pixel color. And then we can plug this in. So that now if we take a look at our node, we can see that we have this thick black line following the position of our divider. I can change it to be horizontal as well, and it will follow the direction or the position. You can invert the sides and it's not going to affect it any. I can also change the line width to be a little bit thinner. And if I want it to be non-existent, I can bring it all the way down to 0 and we can see that the line is no more. And we can even change it from grayscale to color and it's going to work as well. It does not care about the data that we're providing it because it's all color space agnostic. Now, finally, what I want to go ahead and do is I want to just expose the output color of this line so that we can change it if it kind of conflicts with the underlying images. So I'm going to go and expose this, and we could just say this is output color. Actually, you know what? I should give it a name. I'll call it line color and hit OK. And let's just call this line color, if we spell that correctly. And maybe rearrange this to be up around our line width. So that now if we come back out into our node here, I can go ahead and play with the color as well. And so now there's one final thing that's kind of annoying me about this node, and it's that we're able to see both our grayscale and color inputs at the same time, even though you and I both know that we're only able to process one pair at a given moment. So I want to do a bit of a visual kind of cleanup for this node, and it's going to include hiding one of these pairs when we're in a given color space. So if I come back into this node here, and I double click to go into our parameters, I want to go and select our bool color space identifier, and I'm just going to copy this into my clipboard because we're going to use this to determine whether or not a socket should be shown. So if we scroll down into our inputs, I'm going to just hide our grayscale ones for now and open up our color. And if we scroll down, we'll see that there's this visible if section. And this is going to be the way that Designer allows us to effectively hide or show these sockets using a particular type of expression. And now I'll link you guys to the official webpage to show you what the expressions that this particular field is looking for. I'm not going to explain it too much here, but if you follow along, it should work just fine for you. So we need to type in input and then a left square bracket, a parentheses or a double quotation, and then I'm going to hit Control V to go and paste that Boolean identifier for our color space. And then we need to close it out with another parentheses and a closing square bracket. And I'm just going to select that and copy to do the same exact thing for our color space, color identifier 2, and paste that there. So now we can go and close those color inputs. And if we go and take a look at our grayscale, we're going to do effectively the same exact thing, except we're going to provide it with an exclamation mark and then paste this in. And what this is doing is effectively saying if the Boolean color space, which if we take a look at, is false, right? Because that's the grayscale color space. This is going to show the grayscale inputs instead. So I'll go ahead and type in exclamation point and bool as well. So that now if I go and take a look, we'll see that on this instance of the node, because it was already instantiated, it's not going to show up, right? Because we already had nodes plugged in. But if I take another node and drop it in, and I go and switch between our color spaces, we can see that it's going to switch between those input sockets, and we're not going to have both pairs showing up at the same exact time. Now, before I leave you off, I just wanted to give you a couple of bullet point ideas for maybe ways you could kind of improve upon this node and things that you could use to challenge yourself in the future if you wanted to continue with function graphs and pixel processors. So one way is that you could take the dividing line that we have, this position, and figure out a way to have it rotate based off of using two different GUI handle positions. Or you could even take a look at trying to find a way to add the ability to have multiple blended images in this node, not just blending between two, but possibly upwards of 4 or 6. So hopefully those ideas will get you started and up and running with taking a look at how you can take this to the next step. And as always, thanks for watching, and I hope you guys learned something new.